In case you're wondering if this is my usual deep voice, it is for 4 o'clock in the morning.
That's okay.
Okay. Good morning. I am James Foster. I am here to discuss GemTalk and the Gemstone database. First, we're going to discuss the company, and I'll give you a little bit of history and customers. We have 42 years of continuous operation, but as is customary in the technology industry, that tends to go through lots of different vendors. And so we have founded in 1982, name changed, acquired by Brocat in 2000. There was a lot of technology excitement around that time, and then the German company that bought us failed rather quickly and spectacularly, and the management buyout occurred in 2001. Later, we were acquired by VMware at a time when VMware had about 8,000 employees. 3 years later, VMware had 14,000 employees, and we were the first divestiture that they did when they started downsizing. So we were acquired then by one of the executives, Dan Ware, who now wholly owns it as just a small company. We're going to try a different microphone.
Yeah. I'm not sure if it's going to work.
Right. Well, it's turned on. Now we're just waiting to see if it gets. Nope. Not so good. Not so good. Okay. Well, we'll go back to this one, and it'll fade in and out, but you'll be able to hear me still. So, some of our customers. Financial trading, JP Morgan, Facultad is an application that's generally considered one of the most sophisticated applications at JP Morgan and handles the exotic derivatives trading. I believe I checked yesterday, and JP Morgan has developers in Buenos Aires, so there is a team of people working on Facultad using Gemstone and there. Intercontinental Exchange, Momentum Holdings, Liveware is one of our more technologically advanced companies in Switzerland. Guava is a product and a company that does financial treasury systems in Australia. Manufacturing, Texas Instruments runs their fabrication plants using Smalltalk, and we're part of that. Onto the semiconductor manufacturing, HTS is a company based in Toronto, and they run a customer management system on Smalltalk. H.B. Fuller does adhesives in Minnesota, the United States. Florida Power and Light runs their trouble call management system on Smalltalk. And telecommunications, Telecom Argentina is a customer here, and I spent a day with them on Wednesday, and many of them are here as well. ITOS, SGL, others, government, border security for Canada, the visa processing for Norway, Dutch Agricultural Institute. Then, thank you. Then we have a number of companies that are value-added resellers. So a number of companies will use Gemstone in their products that they sell to others. Or we will work with others to incorporate some of their products into what we do. In community, we are a sponsor for this conference, as well as ESA. We support the Faro Consortium, so we do try to stay involved in the community. This is a fairly recent picture, though there's maybe one or two since then, of our team, staff, developers, support, and in the center there in the blue, at the front center, is the owner, Dan Ware. So, a little bit of a tutorial on Smalltalk in Gemstone. And of course, many of you are familiar with it, but we do like to give some explanation of it for those that are new to the area. The traditional Smalltalks, whether it's Faro, Squeak, or one of the commercial vendors, are limited to one virtual machine, one object space that lives on one host. The space is generally limited to RAM, so you might have a few hundred megs if you have a very big image, but that's generally a limit. And then if you don't save your image, then when it crashes, you lose all things you've been working on. And saving the image, if it's large, could take several seconds. And so that's a degree of overhead and complexity that we would like to avoid. Gemstone addresses these situations by giving you an object space that's visible to thousands of virtual machines on thousands of hosts. So you can distribute this horizontally very well. The object space is limited by disk, not by RAM. And essentially terabytes in size. The design limit is quite a bit larger. Then this is what we refer to as ACID transactions. And this is database terminology for atomic, consistent, isolated, durable. So Gemstone provides the full database experience as well as the full Smalltalk experience. So that once you return from a commit transaction, it will guarantee that the data, the changes you made are persistent. And if the system crashes, you can recover to the point where that commit occurred. Scalability, again, billions of objects, thousands of users, thousands of machines, thousands of transactions per second, terabytes of data. So this scales. Concurrency, again, multiple user sessions, multiple users, VMs have visibility to the shared object space. Built in are the transaction semantics, so a Smalltalk message send will do a commit, an abort. We have reduced conflict classes, so some things like collections that would often end up being a conflict if two people were modifying a collection at the same time. We have classes that help get around that. There's pessimistic concurrency. Again, databases have the concept of concurrency with a pessimistic locking or optimistic locking. We support both of those, but you can explicitly lock an object at the object level. So granularity is very fine. And then no one else can commit changes to the object while you have it locked. Namespaces, again, we early on had namespaces because it's a multi-user system. Security. Security is something that's expected from databases and object level security. This is much like file level security that you might find on your operating system, where you can limit read, write by owner, by group, or by world. So you can specify whether the objects have visibility to different users. And that is built into the virtual machine, so at the time you send every message, the virtual machine checks the receiver to see if you have permission to send a message to that object. Login, again, this isn't something you just open simply on, double click on an application icon directly. Instead, you need to provide some sort of authentication. And Gemstone supports user ID password. Also, in enterprise environments, there's often a desire for something like single sign-on, supporting LDAP, PAM, X509 certificates. Again, if you don't know what these are, then you don't need them. Some of them I'm not as familiar with, but I hear some customer wants this, so we added it. Then each user can be given certain privileges. So again, things like resetting someone else's password is something that is a common scenario in system administration, but it's also something you don't want just every user to be able to do. So you can designate certain users to have certain privileges. It's 100% small talk, turtles all the way down is the expression. All objects, all the time, classes, methods, blocks, exceptions, ANSI compliant, with generally some enhancements for collections. Other than that, and then transactions, database management, but otherwise, this is a non-GUI small talk. So ANSI small talk defines the collections, blocks, and so on. We support all those things. Particularly the enhancements for large collections, because to a large extent, any Gemstone database is simply a collection of objects. And the scaling simply is a matter of a collection will have more elements in it. And so a customer list, a parts list, a vendor list, and with support for indexing using B-trees. B-trees are a common database structure, and yes, Gemstone uses B-trees, so that you can, with a very small number of reads, you can navigate to a position in a very large collection in essentially millisecond access time. So you can look up a particular user, equality indexes, identity indexes, interfacing to other small talks. As mentioned, Gemstone does not have a graphical user interface. And so this is, again, I mentioned some things that we have that the traditional small talks don't have. Traditional small talk is largely the origin of the graphical user interface, at least for popularizing it out of Xerox PARC. So we do not have the graphical user interface. We rely on other technologies for that. Historically, that has been other commercial client small talks. So the VAST platform, which used to be VA small talk, which used to be VisualAge, we've supported that for a long time. VisualWorks from Syncom are the two commercial client side small talks that we support. Then we have some interactions with Pharaoh through a library that we've created. Jade or Jadeite are an IDE environment that is created in Dolphin. We also have a library for each architecture platform that's a C library, which is actually how all of these other libraries interact with Gemstone. And we have interfaces to relational databases, Oracle, Postgres, Sybase, a couple of those are open source. Platforms we support, Linux, Apple, Oracle, Solaris, IBM, PowerPC, Raspberry Pi. I have Gemstone running on a Raspberry Pi with 8 GB RAM on an SSD, ARM processor. Clients, all of the above, plus Microsoft Windows. The Gem Builder product is essentially an IDE and an object replication library, so that you can replicate objects from one system to another. Support for that in the VAST platform and SysCom VisualWorks. Jade. So if instead of creating a UI with a client Smalltalk, with now the web, all you need is a web server that can open a socket and send out a string of HTTP, or I'm sorry, HTML, or JavaScript, or JSON, or something like that. So there are servers that are written in Gemstone so that you can just simply serve a web application directly. Jade is one of those and has a full set of browsers, tools, debuggers, inspectors, and so on. I'm happy to look at that with anyone who's here that wants more discussion. Jadeite is a fork of Jade that is being developed for a customer in Europe that wants certain support for source code control. And so there's new support for the tunnel file format, Rowan, Git, and other source code management systems. Licensing, we have a free license. This is something that can be used for any application, including commercial use. So start your project and deploy it. When it gets big, then talk to us about other licensing models. The community edition is available at certain prices. So we have the starter is something you don't even have to give us an email address. The limited is something where you can do 50 gigabytes of disk. All you need to do is send an email. We're not going to spam you, but we're just curious if people are using it and how. From there, we can increase items, and there's a price that has been steady for 15 years. So there's pretty good arrangements there for you. Support, web support, online, emergency support, 24-hour call, mailing list is where the free support generally occurs. In the last few minutes, I'm going to zoom through a set of slides on the roadmap, the recent releases. We have 3.7 is the most recent version of the product, and 3.7.1 was released earlier this year. 3.7.2 is in the final stages of testing, expected to be released in the next week or two. Version 3.6, we have a January release, so there was something there. So these are the recent releases. Version 3.7 has very significant performance improvements. Everything is faster. And a lot of, then I guess we'll get to a little more on that. We've added support for Prometheus, so system monitoring. There's some nice monitoring tools that IT departments often like to use, and so we've hooked into that. The faster VM, any of you know Andreas Falud, he has worked on the VM to optimize it quite a bit, and we've seen in our benchmarks about a 35% speed up. There's some customers who want to encrypt the data and have the key for the encrypted data held by someone else, and so there's a Microsoft Azure customer master key. So you can encrypt the data and the keys are managed elsewhere. So if someone revokes the key, the database is no longer visible. Instance migration, this is something that I was talking with one customer about recently, and the ability to migrate and commit up to 2,000 classes at a time in one command is something that's very valuable in certain use cases. The OpenSSL, we try to stay current on the security features. So we also have a new SSH class where you can execute remote commands. And SFTP has its own class and the ability to upload, download files. Faster read streams, again, a byte stream that's optimized for reading byte objects. Then Unicode 16 or UTM-16 strings automatically change, much as in smalltaks, small integers change to large integers. We do the same. We have some cryptographic hash methods that have been modified to play nice with Pharo so that you can more easily port your code from certain things that have those methods. We now support file system in a native way. So this is something that's included in the base image with various files that now have a better API and port code more easily from something that has that in it. Secure sockets. So this now can work with pre-shared keys and anonymous transport level security or transport layer security, TLS. Then one of the things Smalltalk in general has is immediate objects. So we saw a discussion on the ZAG Smalltalk of the different immediates that are available. And this improves performance significantly, reduces the space required because you no longer are actually allocating space outside the object identifier or the immediate. We are supporting, I believe, 16 immediate classes for customer use. And so if you want to define a money class, then you can define that, and that will be available as an immediate. One-time passwords. Again, in larger enterprise, the system support people sometimes get requests for, I need to be able to log in and do this one thing. But you don't want them to have the ability of using this user ID and password indefinitely. So you can create a one-time password that they can log in and use to perform a single operation of that. Rowan is a new package manager that's in process. Native code on Linux ARM is something that is in 3.7.1. There's still more improvements in the performance, and then there's encryption key, and this allows multiple private public keys. Again, there's customers that seem to want to encrypt the data for the extents, chain logs, backups, and then rotate the keys. DB transient support for instance variables. So one thing is, if you create a reference to a file or a socket, you don't want to persist that because that tends to be associated with a particular machine and open file descriptor. But if you have a variable that's holding that and you persist the object that references the socket or file, then you end up with a problem. So we can specify, do not persist this. When you're about to persist it, change it to null or nil. Collection classes. One thing about dictionaries is when they expand, you need to move all the elements, rehash things. What we've done is implemented a new type of dictionary and set that's actually a tree-based rather than the hash table-based. And so this supports much better performance for increasing size, scaling. External session, you can fork a session from one gemstone into another. 3.7.2 coming up, more secure sockets, more certificates, login with OAuth 2, so this is a JavaScript web token or JSON web token. Traits, so some of the attributes of traits from Pharo are being brought into Gemstone, though the API will be a bit different. Here's some things that are going to be supported, some things not supported. We've got some documentation on that. Rowan, again, a package manager, trying to decide what gets loaded. A Sparkle is an IDE that is being looked at for Pharo. Network protocol support. Jadeite, again, using the package manager. GemConnect for Postgres, for RabbitMQ, so this is ability to put things on a bus and a queue. So that's the slides I have, and I don't know how much we should go over time, but if there's any questions, I think there's a microphone that may work better than this one.
Great.
Yes, so feel free to ask questions. Otherwise, I'm here for the rest of the day, and as some of you have discovered, I'm rather passionate about discussing Gemstone and Smalltalk.
I have a question. Oh, sorry.
Yes.
Because when I competition with the salon, when he comes, have to tell him. I made the question.
Yes.
Anyway.
That's all. You ran out of your time.
So my question is, you mentioned that you made a lot of improvements on performance.
Yes.
But you only mentioned 35% faster on the VM. What about the other part? Because you mentioned that you make improvements on different parts of the Gemstone technology. So do you know how much are those and those kind of things?
So the performance improvements have primarily focused on the virtual machine, not on database, although there are some other things that are involved. The shared page cache, there's some support for keeping more of the database in the shared page cache, and so on. No, object management has not been the focus. It's been primarily aimed at, we have some financial customers that are doing lots of calculations.
Okay.
And here is where the VMs that are in VisualWorks, in Elliott Spur VM, is very, very fast.
Okay.
And so we're trying to get some improvements in VM for just raw math.
Okay.
And just message sends for objects that are already in memory. Other questions? Okay, again, I'm going to be here and love to show you, help you get set up, download, show you tools and other things. Thanks very much.
Well, good morning, everyone. I am Carlos Ferro. Contrary to what the schedule says, my name has the final S. I want to start giving thanks to FAST for providing me a captive audience since 2007. Every year I want to give a talk here. It's a very nice conference. So I want to thank the organization and of course the Universidad de Mar del Plata engineering department because we feel very welcome here. I will talk about a tool for our main system, dia3. This is a picture of our team in this project. So I will start with a brief introduction to dia3. In a past conference 2 years ago, we compared dia3 with a theatrical play. dia3 is a business simulation for the oil and gas industry. It simulates the evolution of an oil and gas extraction project. So it calculates the future production and makes some economics and financial evaluations to provide decision support. It started as a basic calculation engine and then evolved into a simulation. In this simulation, we have the main objects representing real objects in the project, like reservoirs, wells, facilities, and rigs, and some non-material objects that are real also, like jobs. And this is enforcing the metaphor of the theatrical play because we have actors. Actually, we call them simulation actors frequently. This artifact is the surface layout. It depicts how things are connected in the project. And continuing with this theater thing, it works like a scenario, because you set the position, the marks for the actor, where they will be, and how they will move in this scenario. And the script is like the job's scale, because this is what defines the actions of the actors. The dialogue lines will be, in this case, the jobs realized on determined objects. With all of this, then you start the simulation and it runs. So the actors play their part. There was produce some fluids. The fluids go through the pipes and arrive into the facilities where they are processed. And this goes on and on until the end. But we could use another viewpoint for better. And, well, there was this guy that says that a new viewpoint is like some amount of IQ points. So we could take some advantage of this new viewpoint. And that viewpoint is to think better, and not only as a play, but also as a program, an object-oriented program. In Facultad, each simulation actor is instantiated from something that we call spec, which is the specifications that the user needs. And this instantiation process is very similar to class instantiations. Actually, we have an instantiation protocol for the specs that is mainly this message or variants of it, which is as simulation object in a raw filter. This is the kind of messages that are sent in the preparation stage of the simulation. You build a world with all the specifications instantiated into that world. The simulation is like an event-driven simulation. It has a loop of steps, and the steps are, in this loop, are like instructions in a program. You go from one to another, you have the loop, go to the beginning. This, for instance, is the main step message, the word step, which distributes in turn the step to different objects in the simulation. So now we have that viewpoint of Facultad as a program. We can start to connect this viewpoint with the things that we as programmers usually utilize to work with programs. So we have editors. We already have editors in the graphics interface of Facultad, which, if you look them a bit, are somewhat similar to an IDE, a classic IDE, where you have the tree of objects on the left and a large pane in the right, where you usually see the code. In this case, you can see and edit the properties of the specifications. On the other hand, we have the runtime. the runtime of the simulation is pretty raw compared to this. We only have this like progress bar while the simulation is running, and after that we have the results view where we can view and analyze results, see some graphics, but during this runtime we have not much information about what is happening in the simulation. So we started to think that we have a missing tool there, a very important tool, which is the debugger that we use at the runtime to see the flow of execution and inspect objects during the runtime when they are live and so on. At the same time, we had this event in the company, the hackathon. It is written fancy with a Q because the company is formed, but it's a normal hackathon. A couple of days where our teams get assembled from different parts of the company to work on some ideas that are not in the normal plans of development. We have this Beamer tool, these bubbles here, where the ideas are defined, and then we have some schedule to pitch the ideas, recruit the team, and let them develop and show a demonstration. In this case, as usually, we are small talkers, so we cheat a bit with the system. We don't propose an idea to recruit people from the rest of the company, but we build our team of work within our development team. And this is the funny picture that we had to present as one of the events in the hackathon. Well, you can recognize Guillermo, that was here yesterday, and me, Sebastián Baldaque, and Alejandro. And this picture is nice because it resumes, well, the name of the team, which of course was suggested by ChatGPT, and we liked it. And this sentence, which defines the purpose of the debugging tool, to stop the simulation, and that's why we call it pause pattern, because we wanted to pause the simulation to watch what is happening and get some understanding. Well, it's demonstration time. And this is Petroviar. We have a demonstration project. I can see the surface layout. It is simple, but not too simple. It has some amount of reservoirs, different facilities, which are connected here. And I can run the simulation. And as I have said, you see the progress bar advancing and nothing else until the end, where you can go and see the results. For instance, reservoir production. Let me make this a bit bigger. Well, here we have some production starting to go. But then we added the debugging tool. And here I can go step by step, so I see that this flare appears pretty quick in the project, and some other facilities are starting to work here. And of course, as it is debugger, I can set a breakpoint, for instance, in this panel. The first idea for breakpoints was to use a date condition. I could set a false in March 25. The breakpoint appears here. I have some watch expressions below, which are by default the main indicators of the project, the oil rate and the oil fume production, same for gas. And now if I run to the next breakpoint, it advances until the date which I specified. I can also use some other conditions. For instance, I could go until the project has a cumulative production of oil around 5 million barrels, for instance. And if I go now to the next breakpoint, it advances a bit more, and I can check here that the oil cumulative production was high, so it's alright. And another type of condition that I could use is on a facility. I could say, well, let's see, when the rate of the separator falls below some value, 4,000 barrels per day. Now this runs a bit longer, but I can make the pause here and add another watch. In this case, I would like to see the variable on which I set the condition. So I pick it here and add a new watch. Now it is in 25. I can go on.
May I ask the question?
Yeah.
So here we are debugging the simulation, but how can you find if there is an error or something? Because I'm just making the analogy with the debugger, small debugger, and you see the code and you can change the code and those kind of things. But I don't see that here, so is there a relationship there or not?
No, because there are no errors in the simulation.
Okay.
The things that happen in the simulation is, for instance, that the customers usually come with a question like, why in this period I have this result?
Okay.
So that is the kind of things we want to simulate. So our watches are in terms of...
And how do they know why is that number? How do they go to the simulation and see why?
No, the debugger provides us is, for instance, to see when it happens, and then we can go to the schedule and check what is happening at the same time.
Okay.
So it's not a programming debugger.
No, okay, but yes, looking at the results, you can then go back and see what happened.
Yes.
Okay.
Well, I can also rewind the simulation, run it to here. And well, how does it work? I can go into some implementation details. The first thing is that we wanted to produce minimum changes to the simulation engine because it is something that is working since a long time, and we don't want to break it just for having a new tool for us. And we succeeded with that. The only change we introduced in the simulation is to trigger this event in the work step. So this is the only hook where the debugger comes to make the rest. The second part is that we want to have this graphic animation of the surface layout. And we used for that something that was already there in vector simulation, which is a variant of the surface layout that can draw the simulation world instead of the specified world. This was an existing component, the simulation surface layout pane, and we added a property there, which is like a dynamic instance variable, to hold the debugger, so the objects inside this graphic pane can talk to the debugger. Next, the watch points and runtime variables that I have shown. These are the watches, and this editor that I used to define the expressions that I wanted to watch along the simulation is something that we already have in Vector. This variable pool editor pane is the same that we use to edit function variables in the specification. So we only have to connect it to produce a runtime variable that works like a watch point. As for breakpoints and the different conditions that we can have there, of course, they also were in the system. We added a new graphics interface, this simulation breakpoint pane, but most of the code we got from this yellow thing here, which is the pane we use to edit the conditions to trigger a job. Because we use basically the same condition hierarchy for the breakpoints in the simulation. And finally, the magic of smalltalk processes allows us to pause, stop, and resume the simulation process. So all the toolbar of the debugger works with the debugger having this new process during the build stage of the simulation to debug. We just set a new process that executes the simulation, and in this build simulation up here, we connect the debugger to observe the step event in the world that is built. And so, well, the step notification we get on every simulation step. If well, we update the watch expression, then check if some breakpoint should be activated, and then we suspend the simulation execution block. And resume is, of course, resuming the process and all continues working. And the same when you go step by step with the button, it just sends a resume and sets a breakpoint for the next step, like the normal debugger. Well, this is pretty much all I have.
Hey, Carlos. Great work. Imagine, very complex scenario. When you are debugging, when you inspect, can you modify inspecting during the debugging part of the underlying model of the simulation?
No, this is something like Hernan asked before, and I can do that in the development environment, of course,
yes.
The same as if I would have a hard breakpoint, like a hard in the code, but not in the runtime version.
Thank you.
Just a quick comment. Can we go back to the last slide? The one with the exactly. At the step method, when it activates a breakpoint, on the first, shouldn't the process be suspended before modifying its data to stop and trigger the event to avoid a possible race condition?
I really don't know. We just tried the minimal thing that worked, mainly because the hackathon are 2 days, so once we got something running, we stopped.
I just to check only the process suspend line 2 lines.
Yeah. It makes sense.
You mentioned that you did this in the hackathon, and this is like for the end user of the application, right?
Yes.
Did the user get to, are they using it now?
No, it will be in the next release. We had a release just a week after the hackathon, and of course this requires some maturation and quality assurance before going to the final users.
So I think this is the most important question. Did you win the hackathon?
No. And we win by participating. It may not seem a lot, but take into account that we are the only smalltalk team inside a large company with hundreds of developers. So it is not minor to present an idea like this.
No more questions. Thank you.
Can I ask if anybody is a Squeak expert and knows how to use the book more? If they do, please come and see me.
The what?
The book more.
Oh, the book more. No, yo cuando hoy en la mañana puse a ver estaba deseado, por ahí no
on machine all the time, even the exams, with TDD, we created a curriculum that I think is really successful on teaching it. And we also reflect on what we did. We had some theses that analyze the process that we're using, how it impacts on learning, and we also develop tools, many tools, with students like Dr. TDD, Cocoras, TDD Guru, Testing, and now baby steps. We made a survey with students about what is the most difficult part for them on TDD, and if we remove this 31%, that is that testing before coding in general is difficult, because yes, it is, then the part that is more difficult for them is the second step. Yeah, 65, 60, and 60% of them think that is the most difficult one, and that's the part that we tackle with baby steps. So now,
this is going to be difficult, I think. Okay. As Arnaud was saying, baby step was designed to actually tackle these step 2 and step 3 difficulties because the writing of a test wasn't really something people thought that was something hard. So baby step is born as a discussion first of two people, Sergio Freddy and Juan Morena. They are from Cuba, and how to better teach TDD. I don't think this is actually working. Okay. Because I have a really strong voice, and I think everyone is feeling me, but this is for the record, right? Okay. Then it evolved into a collaboration between the software engineering courses at Cuba and STEM, Facultad. And it kept growing based on ideas and continuous feedback from the students. This collaboration is running years now. It connects two really powerful ideas. The idea that if we can provide the tests, because if we can provide the test, well, that, as I already said, no fields are actually difficult to run. We can use those tests to validate if someone is getting ahead in the partial solution. How? Well, if a solution passes a given test, it shouldn't pass the next test. Okay? Because if it passes the next test, then the solution is more general than it should be, right? That's the whole idea of the whole thing. I give you a test, and you need to pass that test only. If you also pass the next test, it means you are getting ahead. As the tests are provided by the tool, we can differentiate small tests, you can differentiate small tests. I'm sorry. I'm not used to talking in English on a big audience, so I'm sorry.
It's a small audience, it's a small talk.
I'm really sorry. Small tests are the ones, the basic tests are the ones that only pass the current test. From big tests, that is where you pass the next number of tests on a single solution. So we made a tool that we want good points, writing code that passes the proposed functional test, taking only small tests, and penalize, subtracting points, deriving from the guidelines of TDD. Also penalize if you hard-code solutions, if you never generalize the algorithm you are trying to do, and if you take too much time thinking, doing something called analysis paralysis. I think I hit the microphone. So that's the whole point, to try to make people get used to making algorithms in incremental iterative in an incremental iterative way. That's the whole point of it. Not to think an algorithm like something atomic you actually copy from a book. Instead, thinking it of something that you can refine and you can make step by step, partially, attacking partial domains. That's the whole thing. So, DDD, many steps is going to use something called games or katas. The things, katas are on the DDD world exercises designed to practice your skills on DDD through repetition and reflection in a safe and controlled environment. The name kata came because it's based on some metaphor of the martial arts world, in where you practice and practice and practice, and through repetition you actually incorporate those skills. So baby steps implements different famous katas meant to learn different key aspects of DDD. They are famous for a reason. And we designed baby steps to actually be easy, flexible to add more games, more katas easily. So, wait a moment. Are you tricking me? Are these games or just exercise from a guide? Remember, we do this on the context of a course at the university. So, we may call this, but aren't these just exercise with points? Well, yes, at the end of the day, the games are exercises we want the students to do in order to incorporate the techniques. But we didn't just make the exercises at one point. We gamified the whole thing. So, what is gamification? This is not meant to be a theory about gamification. There are thousands of other studies on this, but it's the use of game elements and mechanics in non-gaming context, and it was relatively proved that can be used in education to improve motivation and enjoyment of study, and hopefully result in higher learning results. So some features we gave baby steps were we gave baby steps achievements. They are like missions to motivate and reward players, feeling a sense of accomplishment of what they do and what they actually resolving an exercise. We gave them badges. We gave them player levels based on those achievements, so they can have some kind of recognition for their hard work. Also, those unlock new content. We gave different game modes. One called support mode to actually contemplate and reduce pressure on less advanced studies, and we also gave an expert mode for highly competitive ones. We even did leaderboards, so you can see how different peers do an exercise and actually see their solutions to the problem. Well, in order to do all this, we actually had some architectural challenges because we needed to take things online, right? We couldn't just do a monolithic small program. So we use a simple client-server architecture. We try to get things simple. We designed everything centered on a small intelligent client made of this university, and we wanted to do the server as time as possible, use it mostly as a data repository to back up the progress of the students. Very important side effect of this. Well, we started having anonymous student usage and statistics available to analyze. This is not really important, and we are going to try in the small time we have to do some kind of live demo. This always works badly, but I will try to do it. So, that's my style. So, let's see about this. This is very comfortable. Yeah, I recommend doing this all the time. Okay, so, okay, thanks. So, okay, let's see. How do we start this? for this to be some kind of workshop originally. We actually meant build a kata for you to use here and do some interactive. The time and the organization didn't help. So I'm going to just use the most simple kata we have, and we are going to try to show it how it works. Well, first things first, I will allow. Okay, so we have this main thing. This is the game launcher, right? So we have right now 11 games, 11 game katas. Basically, these are all famous katas, and as I said before, are meant for learning different things about DDD. Let's use the first one, the only one that is in Spanish. Okay, that is contador. It means a counter. We're going to make a counter. So we're going to. This is my user. This is the code past 24. As I said, this was a demo for you. I have no level, nothing achieved right now. You can change the user and why the enter is not working. Okay, let me see what is going. This is what I told you that I was having trouble. I don't know. That's our name. Yeah, I'm going to. Yeah. As I said, technical problem. So I will just close this and open it again. I'm sorry, really sorry. Let's see. So I'm just going to do this. Nothing. Let's try this again. At least I have the keyboard now. Okay, let's do this. So I'm sorry about that. Let's do what I. So this is the launcher. I will select contador and do start. This is the mode. These are the different difficulties. First run is just make the first time you approach the kata, and you can only do it one time. And we register how well do you do that one time, the first time. Then you will have an expert mode to try to do it better, and a support to log mode that you will have available the solution of the problem, step by step. The problem is if I want to start it now, just do the first run fast, right? You can do an export or first run. Let's then do first run. So this is some kind of assistance actually, right? We will have time. The thing is telling me you have 3 minutes for one step, and you have a definition. This is in Spanish, sorry, that you need to design a counter. So let's try to do that fast, really fast. That's the name of the counter. The assistant do something like this. You press next. Oh, I need to discuss sounds. I don't know if it's going to be heard, but has sound effects and things like that. Using metaprogramming, there was some delay. That was you. Okay. Using metaprogramming, the game gives you the first step you need to pass, right? Make a contador, make a counter. So let's start doing it. If I press next, the thing is going to say, hey, come on, you need to pass that test, and start making me losing points. So we need to pass them. So let's do this. Try to do this fast. We declare a new class, contador or counter, and we have it right here. And what is what do you need to know how to respond? Well, the message valor, right? So let's make it respond that message. So valor, and we need to do the simplest solution available. So what do you think? Oh, this is not a cat, sorry. But what do you think it should respond? 0, right? Exactly. So we just respond by 0, and we are actually doing the algorithm in a really partial domain. We are actually hard coding the solution, but it's the minimum solution we need to pass this test, right? So, well, we press next, and voila, the thing says, okay, we pass the test. Okay, so, I need to go faster, I tell you. So, I really thought it's fast, but I never reach any timeline ever, okay? So I'm really sorry. So we need to pass the next step, and the next step, I'm sorry, and it says that we need to increment the counter by 1. So we need to do that, right? So if I do that really fast, or try at least, where are I don't know, I will open another window because I can. So we actually need to make something like this. We need to initialize in what value? Thank you. So I will put something like this. I will declare this as an instance. And now what? Valor, it will be value, will be valor, right? And we actually need to make the message increment, right? So now, what do we do here? If we actually do something like this, that's what everyone, I suppose, is thinking, this should work, right? Let's check the test. This will pass the test. So I will press next. And something wrong happened. I mean, why did it work? Wait. The thing is saying, this is in Spanish, I'm sorry, because it's Spanish, but it's saying that we are getting ahead. Why we are getting ahead? Because this is not the simplest solution we can do to pass this test. What is the smallest step available? What is the baby step to do this? Exactly, thank you. I played that guy. So what we actually need to do is something like this to do a baby step, right? So now, if I come back to here and do next, it actually recognizes that this is the baby step. And now we see the next step. And obviously, this is the correct test to actually do the original implementation of incrementing 3 times. Well, if we go back and there are people using it, okay, thanks. So we got a really good audience here. So if we come back to the model, and we actually do what it was written originally, something like this, it will now run all the 3 tests, and we will finish the kata with a horrible grade that will rate us in the number 218 in the leaderboards of the kata. Okay. So okay. So the important thing is that now, with the game finished and run, see what happens here. We actually, when we finish Contador, we have now unlocked the next mode. Now we have a mode that actually will do everything for us. Not getting any points, but making the solution automatically, so students will see it. This is a really simple one. The other ones are really more challenging than this one. This is for a demo. We made as a leaderboard available for everyone here, where all the katas of the games are available. For example, Contador on first run, and these are all the results of all the students doing it, and you can unlock if you actually use a user ID that actually finish the kata, you can watch the solutions of all your fellow students. Okay, there are different levels of difficulties. All these are actually students who finish all the different katas on the course. Mine is not given. If I put Nicolas Rinaldi, it may. No, I didn't do it on expert. Here, Nicolas Rinaldi, and I press play. Here it is, the one from Fast 24. I'm actually 152. I don't know why this number doesn't divide. Okay, don't worry about that. And all my statistics. Okay, so let's make some conclusions for this. Let's go back to the PPT, the presentation here. Okay, let's put it right there. Well, we have some results. As I said, we have data. During the first semester of 2024, we didn't have very steps gamificated. We only have the games with points, but that was it. When we put the badges, and I didn't show the achievements, we have all that. We probably have unlocked some things by doing that. Well, we actually made more people practice. We actually had the triple rank only by putting leaderboards and achievements and missions and things like that. And we can actually see how they do, right? And the early results of this is that in the first 3 katas they made, the first one they get ahead like hell. I mean, like 60% of them made a mistake I did by now with the counter. They get ahead, they didn't understand the process of making the simple solution, that, as we show the numbers, was the most difficult part to do. But when they do the second kata, they reduce that number to 23%, and when they do the third kata, they just put that number to 50%. So, that's not definitive, but we think they are actually learning that this thing actually can work to make TDD more available, faster, and better. And we have some other side effects that we actually were hacked by students. People who never want to do an exercise and they only want to pass the course, and the only way to actually make them interested in, I don't know, exploring the environment and learning is by giving them final points, awarding them with points, and again, well, they did want to be first on the leaderboard. So some people actually started understanding the environment, understanding the game, and checking how it worked. That was awesome to actually give them millions of points and finish the game at 0 time, so they can be first, and then they try everything to do at least. So it was possible. It was for learning. So what are the future goals from here? Well, we are trying to improve the way the solutions are run. Maybe we would like to actually analyze the quality of the result, so we can differentiate not only by time and points, but also if the solution using the cardinal programming is actually a good solution, or versus something really operational that no one understands when they first saw it. We are thinking of doing the variation paths, so we can actually attack also the step 1, the one that you actually make the test. Students take with some crazy multiplayer ideas, something like head-to-head, something like erasing the test or erasing the solution. I don't know if that is going to work, but we would like to actually analyze and check if that is going to be a good idea for learning. Maybe use the dynamic class library from Juan Buletich to improve it, to make it easier for the game to be integrated on any quiz image, and obviously improve the security and authentication of the source. The problem is, this is important. They have the source code, so they can actually go see how the game is made, how it uses metaprogramming and changing so they can be first on the leaderboard. So we needed to authenticate the code, but it wasn't really enough. I'm really sorry I went in a rush to try to show you an idea of what to do. I would like to speak about this all day long, but we didn't have that time. We really wanted to make you make Docker or another one that we made especially, but we didn't have the time or the infrastructure to do it. I don't know if you have any questions. I will start speaking a little more slowly now than is possible. I don't know if you have any questions. Yes. I am not the only one with the difficulty. I feel better now.
I have one question. I saw that this is really great for the step 2 of TDD to implement the smallest one possible, but I also believe that you could still create a bad design. So at the end of the day, does it some kind of reflection on the final design that you did? For example, if your solution only had pure ifs instead of doing abstractions or creating classes, or that's something it's hard to do?
Well, two things about that. Obviously, the principal thing is the tool that make the baby step, but it also attacks the refactor phase, the step 3, because every time you pass a test, it also checks that the partial domain is complete. So if you hard code something, and you only hard code the test and pass the test, when at some point you will only have like a minimum domain of the object, of the function you're trying to make, of the finish. So the thing will erase all your bonds and make you lose. On support mode, that's the second part of your question, on support mode, you can actually see the recommended solution of every step. We would make that. So you can then check what you did with what we recommend to do, with what we recommend for you to do, and then see if your solution was a good one, if it was only made to pass the test, if it's really if it's declarative enough for us to believe it's a good solution. But what I said before is that in a future world, it may be a good idea to do some machine learning, something like that. That is right now something that is in fashion. To check if it actually to have some kind of metric. So if the solution is declarative enough or not. But so far, no. We can't, except that in support mode, you have a good solution for you to see and learn by example. And I think I'm going to be pushed out of the auditorium.
You have to shout.
Muy bien, la verdad que te dije, porque le daba mucho muy larga la explicación. Salía perfecto. Yo no puedo planear, todo muy vivo.
Sorry. I was going to make some back. That's right.
But it's an old one.
Sí, sí, pero
It's going to stabilize in a moment. There you go.
All right. I really try to stream, but it's not what I do usually, so just try to make better. So welcome to my talk, and yesterday, so there was this...
Maybe you can use the microphone.
It's really difficult.
Speak as loud as
I don't have the stamina to keep it up for 30 minutes. Anyway, I'll try again. Yeah, yesterday I presented our product and the database level, persistence level of the database we created especially for that project, and then I want to present today. Yeah, when it comes to databases, it's super weird because the more presentations I do, the more I think is that I've never been a database guy. So for me, it's almost like I did not choose the database, I did choose me. So because it goes really, really far further, and I always had, as most of them, people that do services have to deal with databases. And in all the thinking, I'm always trying to imagine, what would have happened if the industry came up with a memory that is non-volatile, fast, and cheap. Because so no offense meant to anyone, but databases are a pain in the ass, actually, because it's really difficult, it makes everything complicated. Yeah, I would like to see a world where the database would just not exist because the memory wouldn't be volatile. I mean, we have an image kind of thing where we were close to that imagination, but and thanks, no offense meant, but for me, if you have a database, it should be a library and another product. I think there's people that think different, they call database vendors. But my vision of a database is always like trying to at least reduce the complexity. That's what the talk is all about. Trying to prepare the slides. I just came to my mind that it's now 40 years of database for me because I remember doing someone 40 years before. It was for a friend of mine or a friend of my brother. And I had a C64, and you remember this data set, the music cassettes. And there was a paper notebook where the records, you have this counter on the side that you have fast forward and stuff, and you have a book where the record is the counter, and then you just fast forward to the counter, and then you could read the record. And I just recognized that the principle didn't change in 40 years because that was indexing. It was just a binary, but if I would have rewritten the notebook alphabetically, you would already have it back then. So my history, my path started actually in '95 doing a lot of stuff and SQL. Most younger people think it's a typo, it's not. It was a super simple single-threaded database, but it wasn't the only one affordable in open source. Later there was the typical MySQL, Oracle, Postgres, any SQL database you can imagine. And then in 2005 we did a startup with, again with Squeak, was the first thing I said yesterday. And I tried to avoid that, so I got through Goods, which is one of the old object-oriented database incarnations as Magma. It's one based on Squeak. But in the end it was far too slow, it didn't work, and then I went back using something like Chlor. And people that know me, they know I hate ORs because it's a misconception and they just don't work. No offense either. Later, just when I got back into doing services on the net, there was the combination that we have is using between MongoDB lets you at least have nested stuff, have no schema, but the data is treated a bit more relaxed. So when we have Voyage or Voyage, like the creator, Esteban is an Argentinian, would say it's an object mapper onto MongoDB. So it's over and just slightly better. It just has a bit less of pain. But in the end, so the product that I presented started actually using this, and then there was, for several reasons, I was not really happy with that. I mean, all the databases, if you look closely, like SQL stuff, they have all these, I mean, if you know C, or I always remember about Corva, because you have all these stuff where you have 5 types, like numbers, those strings and stuff, and I say, come on. If we do a product that pretends to be a database, there will be an impedance mismatch sooner or later, just hooking onto another database, so we need something better. And that was the very start of Soil, saying we can do our own object-oriented database, and we just save a lot of headache and get away much faster. So, just for you, with fun conversion, what I'm talking about is like MongoDB, Postgres, SQLite is the exception for me, and Soil. So everyone, when talking about databases, thinks that the nature of a database is that you send your data over the network, but that always misses the point, because it makes everything complicated. You have something to map on SQL and to send it back and forth. But people always think, yes, databases always send data over the network, so there's only 2 ones that don't, SQLite and Soil. The next thing is, with every language you use, it's always you have a programming language, which is Smalltalk or Java or whatever, and then you have to map into some alienated query language, ESL, which is always a pain in itself. So, and then like Smalltalk, why not just do Smalltalk? And then finally, this also results to that actually there's only one choice for me.
Now you have to gamificate.
Yeah. Alright. Where we are right now, it's like James was talking about the currency of databases usually called asset transactions, which means just it's very, very unlikely to lose data or to corrupt the database. That's in a sense easy, so it gives you a bit more of security. Then there's something like called MVCC, multi-version concurrency control. That's the state of the art, which almost every database does. I will present a bit what it means. Then we have also some binary search, like skiplist and B-tree, because if you have a lot of data, so you need to have fast access and conflict-free access to that. Object segments is something we just introduced. So there's 2 segments right now. There's segment 0 for all behaviors. So we also put classes as objects. And then there's segment 1 for the normal stuff, but I imagine having different kinds of segments later, maybe even remote database, Redis, whatever. So we did it from the beginning. So as a transaction, this is, if we just use Soil, it's like downloading Faro. It's from 11, 12, the newest one, and then go to GitHub, load the repository, and you enter that. That's your database installation.
Thank you. You said that it doesn't use network communication and that it supports concurrent access. So, right? So, is that concurrent access from several processes in the same image, several images in the same machine, different machines, a broker, how do you handle that?
So that gets back to the product a little bit. So it's like SQLite, you just have local, you have file system access. In a product, we use a network file system to share the file system across the hosts. But I hope next ESEC or Smalltaks, I will present something
Drilling more, which even eliminates that because the soil is about to go as a distributed database. And you're not just share, but you distribute data, and it resolves a lot of the problem. But now we use a network file system, and that's just good. A network file system that supports range locking, it's called, and we're back to NFS, the good old, ever been there, useful for everything that we use. It's a simple approach and it works. Yeah, so that's the basic. After you've got your repository or GitHub, you can open a workspace right away. Make something like you have to create the soil, and then make a transaction, and there is like in the smalltalk image you have a special objects array, the root objects. That's the one that are not get garbage collected, and everything attached to this stays in the image. Same thing for a database, same thing in Gemstone. There's merely another way to do it, like you tie it to something and then it doesn't fall out. So that's the 3 lines that shows if you want to just make a dictionary into the database, transaction, set it to root object, commit, done. The thing below is that the asset quality about it is that you have a 2-phase commit. So the one thing is committing the data, the other thing is modifying the database files. So a journal is usually a sequence of changes you do to the database, and that's for sure when you commit a database, this needs to go to disk, so there's even pushing the operating system to make that, and then you can take your time to change the database files. If you then crash, you can detect that there is a newer change, and you can replay the journal. That's why a lot of databases call it replay log or replication log. And so we can discuss, but it's hard to go in between. It's on disk, and then no matter when you crash, either it's gone because the transaction just didn't make it. If you commit it's on disk, then there's a checkpoint. That's what usually means that the checkpoint is all the data is actually in the database files. So because even if you see you go on the database file and say there's something new, you can scan the log saying applying the changes in memory, and then also on a new state. So that's the incarnation of ACID, I would say. Major change, really cool. Yeah, multi-version concurrency control is, well, it's a bit exhaustive, but it's a super feature that means just that every time you change something, you write a new record of the thing. So it's append only as well. So appending is much faster in most disk activities. So you write a new object at the end of the file, and the old one still is there. And that means that if you open a transaction, you pinpoint the whole database to that time and that version. So even if someone commits something in between, then you go there and they see, that's not, I'm not allowed to see that, but this has a pointer to the version before, and then it goes down until saying, okay, this is the one I could see, and that isolates your transaction complete from every other commit, so that you can just have a consistent state, and that's what you want. So that's usually, and that's also what makes most of the database stuff is making that happen. Is most of the soil code, because it's really heavy to do, especially if it comes to binary indexes. Yeah, and time travel has a side effect of doing MVCC. I will demonstrate that as well. Yeah, just we have 2 binary indexes. I'm the guy, I didn't do computer science and stuff, I'm a lazy guy. I like the cool and lazy algorithms, so that's why I implemented skip list and Marcus did B3. Because the B3 is the one thing you will have in computer science, and the skip list is just a very simple thing to do. It's just a stacked, linked list stacked above, where you just, you flip a coin, and then you stay on each level. You flip more, you go down. The characteristics is also that the search speed is prolog and as it is in B3, so the characteristics are almost the same. The implementation of the skip list is way easier. And for what we do, it's because in the B3 it always needs to balance. And there's a lot of write action and a lot of access, and the skip list is just lazy outcome. It's like if you're on the same page. So we made a skip list. We're not 100% skip this because we do file paging. So that's everything that writes to this usually is the smallest amount of data read or written from an operating system is 4K, depending on the operating system. So you always align your memory, and then 4K is saying, when I write this, it's the same as the operating system does. So you have the speed to get out. And so for us, the yellow line, which is file pages, and skip is lower top. Then we have a B tree, which is the usual stuff that you have. When you finish the stuff, you realize your and have the same characteristics to binary have O log lookup time. Oh, great. All right, font is big enough, I hope. So yeah, here's a bit of basic API. When you start with soil, you can have create a database and a directory, a directory name, and then create it there. You can open it, or if you go and play with it, you can just make this, and then you just relook it, create it from scratch every time. It goes super fast. We have 2,500 tests, and each of the tests an RCI creates a new database. So it's something else that I need to mention, which sets it apart from usual SQL database deployments and stuff, because you always can't do this. And it's the same thing I had in the slides. You can have, so with this, we just make a new one, and then we set a dictionary, then there's someone coming, adding a key and a value to the dictionary, there's another one adding that, and in the end you make a new transaction, and then you have the dictionary. It's, I mean, there's nothing to show here, but it could be fake, it would make sense. What is different is that if we look at the database, we can now see there is the database version is 3, so that means there's already 3 transactions that we did. Application version we put for the user, so you can have your own model versioning. And we can also look at the journal, which means there is one journal file, which I just created. If we go into it, we see there's 3 transactions, and then we can look at each transaction, we can see the log. So it started the transaction, then there was a new object, then it updated the database version, then it was committed. So it's the second transaction, if you see here, there's just the second line changes, because now the first time the dictionary was new, you write a new object, and now there's a new object version entry, and so you can, looking at soil, you can go down to the byte level. If you see this, you can even go into the entity and then just say, in the end, what you do in the database, you exchange one binary by another one. Because everything, the whole object clusters are serialized with byte arrays, and when you write a new object, you just write a new one in order to do the reverse replace, so undo. We keep the old bytes. So because then you can go back in time, you can just say, okay, well, databases don't remove stuff, but if you re-add the old stuff, you will end up in the same state as before. So that's the usual thing how databases work. I'm not sure where I started, but well, that's the most basic use.
10 more minutes.
10, okay. Let's go. Then there's another thing, because we just added a dictionary, and you can imagine if you have an object graph, it could be really huge. And one thing in every database like Gemstone is not to have the full thing. So in a database like an object database, we have one thing that is, we call it a cluster, objects that are kept together, and each cluster has an address. So, but you can, every object you can make standalone, having its address, which means you can partition your object model in, and that's on an application level, so the application developer decides what to partition. I'm just taking the example from the demonstration yesterday. There are some developers, and I'm creating a few issues, add them to the collection, and here, down there, I'm just saying that the two issues I'm creating and to develop, they should be groups or standalone objects. They're not going into one thing, but each of them getting an address in a database. So now they're in, and now if I open a transaction and look at the first entry, you should see there's an issue and there's an assignee. If you look at the real class, then it's an object proxy. So that's the thing that you have. You write a cluster, and either the object is included or you get a handle, an address to which object, just like it's in the EM or something. You get an address, and when you read a cluster, each address is exchanged by a proxy, so the time that's I had to add real class because in the inspector there's no way, because if we go here, you don't notice, because you have the proxy here with this kind of inspectors, there's no way proxy implements all of the methods. So you will trigger the proxy, you get the object. So, but that's a good thing that if you have a solid database and you have a huge, you just go in the first object, and then you just click through like in a normal inspector, and it will transparently load the objects from the database. And that's super handy. All right. Yeah. So yet again, so we have objects and clusters. So meaning every graph that is persistent is written to a cluster. So all together in a byte array. And if you make them have distinct addresses, you partition them all.
May I ask a question?
Sure.
Sorry. Yeah. You showed before that for an object to be committed, you have to mark it as deleted.
Yeah.
And now you're showing process that could do that for yourself. So why do you have to mark an object as deleted?
You mark when you modify it.
Yeah, but why? Yeah, but instead of having the real object, you use a proxy.
Yeah.
You would go through the proxy, and every time it changes, you know that it's changed. I think to make it more creative, transparent. I don't know if you thought about it or.
Well, when you develop it, there won't be process. So because you always do the object. So even with Voyage, I didn't have time for now. I have some things like there was a write, didn't have a write variant.
Yeah,
I would read all the objects. There could be stuff, but I just.
Okay.
So, but you're right. That's the one thing I don't like about soil because it makes testing and example objects very complicated because you have to use the low-level API. So there's also for the make group, I just make it for demonstration. You have a class side setting, so you can per class you can say this is all instances of that class should be root.
Okay.
But the power of the database is that you can put this standalone thing on each object in each instance. And yeah, I'm not yet there, but I want to. But still, root, so making it root is something which is application specific, so you might make it in another way so it gets out of the way. But yeah, that's the main pain point because I'm trying to do example-based testing. But it goes obviously.
Okay.
Yes. It's not finished.
Okay.
That's the start. Alright, the next thing to demonstrate will be something where you actually, I think even Gemstone, you always struggle a little bit with small talk, you want to all keep it small talk, and then at one point, I think Gemstone had this curly brace syntax or something, you need to have something index specific moving here. We just made it super fun in the skippers dictionary because with the file paging, the optimization is you give it a fixed key size, and then you choose the number of the skip list, how many levels it has, which is more or less the if you take the it's 253 log 2 times, so you just say the expected amount is 1 million objects, and then you just can do the calculations, and then you know probabilistically this many level will be performance-wise will be less, and you can readjust that. So that would be the way that you just created something like a binary index, so a dictionary which is a binary index attached, so it keeps the basic dictionary protocol, and underneath there's a file index which is binary. In order to do this, just made a simple example where there's 100 processes, so there's 4, so there's 100 processes just making transactions and adding a key. So to see that, look at the control file, it was 101, so the first one was the Skippers dictionary, and then it was just 100 processes. So that's while concurrency they all run, well, there's a semaphore protection, and the transaction is just streamlined. That's like in every database. So you have the writer problematic, call it. You only have a single writer, because you have 2, they can stop on each other's feet. So you have everything in parallel until you really go to this, or really commit and assign. I mean, you have always these addresses in the database. You have to do this at the very latest point, because you cannot acquire this soon. All right, let's hurry, because and I wanted to see. So same thing. Again, you have the developer objects, and then you have issues. Then you assign the second issue, the first developer, and then doesn't matter. So you can just look at it, and then you have the second issue, signing or smartness. But as we have each state of the database has a version. So that's every commit advances the database version. So that's a sequence of changes and states. And with MVC combined, I can just make a transaction saying, just to show you, we have now the, if you look again in the database, there's now 3. And then, so that 3 was the last, so I just go 1 back. I'm just telling the transaction. So you pretend now to be only read version 2. That would be the case when I open the transaction, someone else commits something, and I'm still on version 2. And then you do this, and then you now look at the developer as me. Because now the reference to the stuff just went down the version, and that works all over the graph. No matter how big it is, it will just give you a consistent view of everything you reference, which is super cool and not possible in most other databases. All right, so there was the short demo, and the wrap up would be that, of course, we do a product, and I would like to have spent a lot more time into the database, but right now, so for MVC or concurrency to really work, we never remove something from the index, we just mark it deleted. Because I need to explain, because you have one database that removes a key and another one had opened a transaction, you still need to, because the indexes are central, they're global. So then he goes back to the journal saying, was there a change in between? And say, yeah, they removed the key, what was the old key? And then you present it to give the consistent view. This is really hard to do. I mean, that's most of the time we spend making these models. Then multi-index collection is something which you use in a SQL or in any database. It's just you have multiple indexes. The one is by first name, last name, whatever. So you will have object index in a different way because it's a binary index. It just works with one, well, either in one single key or compound keys. And I still need to add, so there will be a dictionary where you can say every object with, could specify an accessor. Like every object that's been added, call the accessor, that will be the key to the stuff. So you can have multiple keys. The counterpart will be query planning because you don't want to specify which index to use, so you will have just a small talk, like a selector with a block. And my current idea is just take the AST and look for for the methods you send, and then you know the properties you want to acquire, and that would enable you to figure out which is the best index to use. But it's a bit far out. And garbage collections has started, so we also don't. So the biggest database right now is 90 gigabytes. Because, I think the real data is maybe 100 kilobytes, but it has a lot over the last year, and so it's 90 gigabytes. And I have first inclination of a garbage collector, but no time on that. So but give it a call. Yeah, so it's, I mean, garbage collection is always like in the database you can have so many levels of cleaning up. So, and the good thing about soil is that the way the database works with the cluster management and the object is completely separated. So so garbage collection you could do without having the application code. Because everything like referencing and everything is mapped on the database level, so the white areas that are on the disk are never consist of any information in the database and vice versa. So, all right. Indeed.
Yes. So I missed how you want things modified. How do you do modification to mark object modified?
No smart code.
So you do it explicitly, right?
Yeah, that's what I'm saying. That's what I don't like, because that's not good and it makes it complicated. It's now you have to mark dirty. So and it's especially complicated because you make this clustering. So you have to think about that root object. You have to know that because the dirtiness goes on the cluster, not on the individual object. So that's.
You know how the global thing works, right? The read-only object.
How what?
Global work by having a read-only object and then show copies of the original.
Really?
That's very simple. So then, what are object segments?
Pardon?
What are object segments?
It's just a way, well, pretend we will need that in the second that we have, because, well, object address in the database is like segment plus index. So it's just preparation to have I mean, I love having heaps well separated, so there is different needs for different objects. So that's the one thing being the segment 0 for all the classes, or behaviors just exists because it doesn't grow that much. So that means the index, the address will be really small. So, and that's just an optimization. And so then everything usually the heap goes in segment 1. But we just put addressing and segmenting so we could, because that to introduce that later will be really hard. So we just made a preparation because I have things like remote stuff and then you just have. I mean, a segment is like an MMU. Like there is one that takes responsibility to get you the thing you want. Yeah, but you just ask to it. So the segment is more you can have multiple entries. And you don't care how these objects are stored. You just say, give it to me or take it. And that's the same thing. You could always tell a story because how I got the same database, the same thing 100 times faster was 10 lines of code. Because there's in segments, there's only add, put, and add. Yeah? So there's only one method that writes that goes to the segment in 1 hour. And so implementing an index was like, making a subclass, override it to, and then say, please recently used cache, add if absent put, super add. Yeah, there was a whole 10 lines, and that reduced the number of disk operation to 1%. And that's what if you do this in a Smalltalk way in the database, and you write in there, you see how easy it is to make something really powerful. 10 minutes, 10 lines of code. Usually. And that's usually with a distinct product environment form that you don't have access to. It's really hard to do. You just need to walk around. And that's something I did.
Here, Laura. My question is similar. I think someone asked while you were talking. It's about the deployment. Yesterday you say that ActiveRead had multiple foreign images. I suspect or I imagine those multiple for image may reside in different machines, in different nodes. So who would they talk to a solid data? So they say I have one image, because the way that you should code is actually be a file system. But if I go, let's say 10, let's say system or 10 whatever worker, 10 images in 10 different servers, who would they talk to the one image with solid?
There's no one image. The architecture is about having the data, every image is the database.
Okay.
So every application code directly accesses the object. The database is just a mediator between the disk and the image. So you cannot do everything. So for me, I can go on endlessly, because people have always had to argue. It's like you have 5,000 databases, so how would you dare? So you have to back up 5,000 databases. And I'm saying, well, in theory, it's 5,000 with the size of 5,000 of size, so it's the same thing, but then I get back, but I just back up the database that changed. And you just back up everything at a bunch. So in the architecture, so everyone expects the database to be far apart, and the same goes for sharding. I mean, everyone talks sharding, but sharding is two design flaws in one. So first, they have multiple customers, they put it in the same database. Then they invent something called multi-tenant. And then, because it does not scale, put sharding in front to virtualize the ID range. And for admin, we're just saying we partition on the user level. So each user has its own database. A firewall image can hold, I configure this, any amount of databases. That's the point. The soil is there's 20, 30 databases in an image. I have 12 images per host. I have 3 hosts. And I have a load balancer that just pins to one ID to one database. So there's just the deployment you can fine-tune, saying there's 1,000 people, I have 30 images, and each image has 50 databases, so you will...
So those 12 images, they all access the same path on disk for that server? 30.
For each database, one. For each user that gets to that image, will open its database on its path. But you can have 20, 30. It's not. That's what people are so tired to have one big monolith database and stuff. No. The database is just to store some data, and I want to have it flexible that you really have any amount of users, any amount of machines. The mapping is just the deployment stuff, how much memory. If I want to have a big cache in the image, what I did with the least use cache, then I will have less databases. But you will always fine-tune, but it's just an association from each user or partition model to one database, and you're completely free. Does this answer the question?
Well, great presentation. Something that you didn't mention, that is like this has some heavy resemblance with OmniBase. With OmniBase?
Yeah.
And I know this doesn't work in Windows. So what is the first question is, even an OmniBase did work in Windows.
Yeah.
And was actually used for the storage engulfing and everything. Why doesn't it work in Windows? What's the current limitation?
Okay, what I did not say is the word that was OmniBase, because I just discovered it. Well, back then I thought OmniBase was just a big monolith as well. And then I just discovered, oh, it's just all Smalltalk. And then I took it, I maintained the code, and it was the first one to change because the file handling code was such horrible things. I mean, OmniBase is not, well, the code quality is rather poor. But the file system handling was awful. You see, everything, the Microsoft factor, every shit they did in all decade and they want to keep, you have to creep into your stuff, into your API. And I never used Windows in my whole life, so just saying, I cannot do it, I don't want to do it. If you want to do it, and you assure me you will maintain it, that's what I wrote in the email. I'm open for Windows. If it's, open source, like, you can do it, but if you just do it and then you don't keep up with it, I have to do it. to it. And that's something like, so there was one user that tried it on Windows. So there's only two things. There is range locking, that, well, for normal database guys would understand row locking is something that means that you have a position from to in a file that you lock. Because that's optimistic locking. It's not like you not making the biggest lock, but the smallest possible. That's using a POSIX call, which is called an FNCTL. So that's not implemented for Windows, and I don't know what. And the other thing is the string fstring, it's called. And that's because if you do a flush on a string in smalltalk, it just gives the data from the image to the operating system, but that keeps it in memory until it decides to write it to disk. And it's saying, for the journal, you need to have an assurance. It's saying, committing ends, I need to have assurance it's on disk, otherwise the whole assumptions fail. And then you put an fstring. And that's the two things that fail. In the meantime, I made both of them configurable to be switched off. But there was some, I'm not sure what he did wrong or does not work. Well, he said it almost works, but for his case, it worked on Linux, but not on Windows, but I could not see well. I would be interested in finding out what that is, because that seems to be a really small thing to change. So you can just, if you want to use it on Windows, just say, I don't need locking. So if you're a single image stuff, you don't need that. So there is even image locking, yeah. So you can switch it off, and then we can see. If the Microsoft file system API is not horrible, which I don't think it is, well, I think it is, but yeah, I just don't want to spoil the whole product just because of Microsoft, because I really have no deal with Microsoft, so whatsoever.
Just before we leave, and the second question is related with clustering. It's like in your sample, you have like a developer instance and an issue instance, and you, I don't remember exactly, but I think in the dictionary you store only one of those, and you mark the only one of those.
Yeah.
Let's suppose you want to have some sort of collection, so you can directly access the list of developers and the list of issues onto different keys on the root dictionary, and you say the issue that references the developer. How you solve that? How do you dereference everything, or everything goes in as a single cluster?
I'm following. So
I can ask you offline. Don't worry, because we have to go lunch.
Yeah. But yeah, the restriction is that for now you have this in one image. There's no sharing for now.
Yeah,
we'll add an option not to use the cache, so it could actually the image doesn't cache and there's file locking, so it could work. But actually, if you add cache